terabytes of data to another choice. Then, for this reason, the company takes a lot of time, and in many cases, like Google, Amazon, and some others, LinkedIn, for example, decided to create own storage. Yeah, 1 minute. We are very close. And
I mean, it's not like all they are telling me that not to start, so. I think you already started, so.
no, this is only no. This is only because I want to understand the people and to localize in some way to say it. No,
we're in the hundreds of terabytes range.
Terabytes range?
No, hundreds of terabytes.
Okay, so.
what size of files?
Several gigabytes.
For each file, that you have a large content. You have not small one. Okay. Yeah, probably you have some. Yeah, it's probably too.
Yeah, we have proprietary database formats.
Yeah, that's probably you use. No, that's I know then. Or by the block size, and you move in some way.
Yeah, and not to have too many files open at once.
Yeah. Well, yeah, this session is based on Restfs. Restfs is a cloud storage. My name is Fabrizio Manfredi for Holman, and my colleague is Federico Mosca. In this session, we try to describe Restfs, but before to start we describe Restfs, I want to give you an introduction on storage and why we are in a change phase. And we try also, we hope to show you how it's works Restfs with a small demo. Well, I want to start with the John Tempesta sentence that notice the data storage globally is expected to grow by 60% every year. No, that's is very a huge amount of data. That means a very huge amount of data. That probably we have to rethink how to store all this data. But first of all, why we have so much data? We have many new devices. We have, like disaster recovery, new problem for the company, and so on. But the focal point is we want to use our data everywhere, and we want to store everywhere. This is the change that happened in 2000. Well, all the time you change the usage of computer, you have a leap on technology. Because we start in the 70s with a tree view, I know because the system, the host was a single machine. We moved to a network file system when in the 80s appeared the personal computer. In the 90s, we start to move faster. Then we try to be faster to divide the information. The content on information, the content type was very large. Was not only program or file like text. That was more complicated, like movies or music. In 2000, now more or less, we change again. No, we are more web-based. We want more storage service. We are more K-value pair. Then something is changed, or in changing, also from the data that today is stored in S3. That in the 6th year, they start from some billion to trillion of object storage in S3 Amazon. Then is that you can understand the curve, and you can understand that we are in a new phase. This is very famous, probably you already know, and probably you know better than me. The technology, the usage have a specific curve. I don't know exactly in which point we are today, but I'm sure that the old-style storage is started to decline. No. And I don't know in which stage we are in the new paradigm, the cloud storage. I don't know if we are innovation, still innovation, probably, because we don't have today technology, standards. We don't have everyone today start to own project. That means we don't have standard, we don't have a winner. Well, for this reason, we started 1 year ago, more or less, the project of Restfs. Restfs want to be an experimental project, and we want to test a new technology, new way, new approach, because now the people want to, or better, the people change the way to store the information. The project is an open source project and is designed to scale up from one single server to thousands of nodes without limitation and scalability. Yeah, the goals were very ambitious, no, because we tried to design the perfect solution with high availability, uniform access, scalability, performance, elastic, and so on. We tried, in our Restfs, we tried to give you an answer on all these questions or this open point. But the starting point, the first starting point that comes from Google, that you can find in Hadoop and in the whole file system of Google, the GFS, is moving computation is cheaper than moving data. We tried to use this sentence on all the solution. And when try to identify the solution, we try to respect these sentences. That this sentence was the drive for all the decision in Restfs. We divide the problem in 5 main areas. We decide we don't have file, we have object. The object is divided in data and information properties, and each information has a serial and a hash to identify. Then you can identify all elements without retrieve it. The second, if you want to move the computation, you need a cache on the client side. Because if you want to reduce the transfer or you want to make some calculation on your file, you need the file on local. That means client side, in special way, call back to notify if something changed on the server without pulling that reduce the number of calls, and persistent cache on the client side. You don't have to retrieve all the time when you restart your computer. You have to only to check the validity of your cache. Yeah, the transmission, when you have a cache, that you can make a parallel transmission, but you can make a different transfer, that you transfer only the data changed. Yeah, today it's very important when you use internet, you probably also here, you find firewall everywhere. Then it's difficult to use a not standard port. That's the best thing is to use HTTP. Then we use HTTP protocol, in the specific we use WebSocket. And also the compression is a very important part because you can use the 50% of the bandwidth in average case. Yeah. Another important thing is distribution for high availability. You have, when you have split the data in a small chunk, you can distribute in more nodes. Then increase the high availability because you have more copy of the same chunk. We are decentralized. We don't have a central point that if you lose some machine, you don't lose nothing, more or less. Last but not the least, the security. Yeah, today in the cloud is very important, the security. We use TLS SSL protocol for the communication, but you can encrypt your data with your key. And also you can delegate external identity provider like Google or Facebook. That in this way your system doesn't store your password. And you can also delegate some administration task, and we use NFS SL4 that we have extend XL equals call. Yeah. Well. We start to explain how it works. We have 3 main words. We have a domain. Domain is a collection of servers, very similar to Windows. We have a bucket that is very similar to a volume, that in the bucket you have all the information. In the bucket you have an object. The object is a small entity in our system. The object is divided in 2 parts. One is the property, the metadata, and one is the data. In the metadata, you have a lot of elements. The properties, more or less the same properties that you have today in inode. You have equals. You have extended properties. For us, the extended properties, there are some very specific properties like how many times you can read your object per second, or what kind of content type is the object, and many others. And also we can, or better, the user can define its attribute. The segment is the list that is equivalent to, I know, the list of the block. That we have more than one segment, that your file, for example, you can split your file in many segments, and each segment contains the key of the block and also the hash of the block. Then when you retrieve the segment, you can check and understand what's changed. Because we have a serial number for each element and a hash for each block. How it works? Yeah, what's quite simple. You have a client, more or less. You make a query to DNS. You receive a list of IP. This IP is a location resource, that resource locator that is the head of your domain. Could be one or more. Yeah, that when you retrieve the resource locator IP, you can make another question to resource locator, and you receive the list of the server that contains the bucket. When you receive all the IP of each server, you can create a priority list. And you can understand who is faster or who is slower or close to you and so on. Yeah, now you have understand where is your bucket. Then now you can retrieve the data. When you want to read a file, or better, an object in our case, you can read your server priority list. You decide which server you can use. You make the question, you retrieve the object information. When you have the object information and you have a list of the block, you can retrieve each block from all the servers that you have in the list. Yeah. If you want, also you can subscribe. That means you can create a callback and the server notify you if something can change in the object that you have in the cache, that you don't have need to check every time. Yeah, that's the last is all the block data, all the information that you have retrieved, you store in a client cache. The client cache is divided in two parts. One part is in memory, more or less, and one in persistent, and is based on disk. In the memory, you have the information, the location, that you retrieve from DNS and resource locator. You have the token for authentication, and you have all the callback of all objects that you have in the cache. The permanent cache, you have the metadata and the data. That is a separate object. This is the client, and this is the server. Yeah, we can identify three main layers. The first layer is an interface layer. We have a business logic layer and a driver. Why we have so many pieces? We have divided in many pieces because you can replace when you want. That, for example, now we use a NoSQL for metadata driver. You want to use a SQL server, you change only the driver. That we can, every day we change an idea, and we can replace the piece without problem because it's divided with a more or less standard interface. For example, now we use a Restfs RPC based on JSON. We also make some tests on REST interface that is only a communication protocol that you can change, you can make experiment. That's in some way, this infrastructure is more a framework that you plug what you want. Well, In the interface, we have the interface for subscriber, resource locator, token authentication, token for session, like cookie. We have authentication system and the metadata and the data interface. We export today also S3 compatible interface because S3 is more or less is a user everywhere. Well, each of these elements are separated server. That means not only you have a horizontal scalability because you can spread your information to more than one server, but you also spread the service in other servers. Then we have two layers of scalability. Two layers of scalability. The client is more simple. We have at the moment we use EuroPython. And we have a cache with a cache manager that stores everything inside in the disk, and we have a connection manager for locator, Restfs, RPC, and callbacks. Well, that's okay. Do you have questions? Too fast? Bad English or some other? No one? Yeah. I think it's good to show how it's worked, that probably you can understand better that all the slide before that. Yeah. Yes?
Do you support server-side compression?
Yes, both. Yeah, or rather, it's planning. We can compress on client side. We have also compression in the server side. And we start some experiment for the duplication. No, that's we check. We have the hash that we can understand if the same block is already present, and we increase the counter. With the duplication, you probably you save 30% of space in many cases. Yes, it's a little bit complicated to maintain the duplication, especially with a large amount of blocks. Like another thing, the block size and the segment size is defined by the user, and also is elastic and adaptable. When I receive the size of the file that you want to store in the system, we decide the size of the block and how many elements for segment. Because we have segment. We have segment because today, in special way for media content, you start a buffering. No, you start a buffering that you can decide which segment, all information that you want for a certain amount of time. Then, this out.
Now I'm going to show you how to use our file system. First of all, you have to have a valid token to use this. You can have one using Google, Facebook, Twitter, or a local database. In this demo, I'm chosen to use a Google account in order to certify my identity. So now I'll log in. I decided to show you how works our S3 interface. So the name of our token is S3, sorry. In this way, on this key, I can access on our file system.
Yeah, the idea of the token is that you can assign each device that you have a token. That means if you lose or stolen your device, you can retrieve the key and you don't have to change anything to other devices. that everything works, you don't have to change the password and change the password on all devices. And also you can decide for each token the validity, and probably we also extend that the information retrieved from a specific device could be happen only in a certain amount of time or a specific day or specific region.
Now I'm connect on our file system. This is a bucket which I created before. And you can put inside some object. In this case, I can put another file to show you. But if I can delete the token of this user. So if I delete, I can be able to show how my bucket expose. When for go inside again, I have to generate another token, another valid token. And then inside again. Our token are stored in an OSQL solution like Redis. In this case, on database number 3, we have all the information about the users and his token. For example, for the user, can I use? We can see every token linked to this user, and the metadata are stored instead on the database number 2. We can see all the data. On the EuroPython.root, we have information about the bucket. And in the EuroPython.id object, we have the information about the object which is stored in the bucket. Now I show you how we transmit the data on our file system. We transmit for difference. So if I put a file inside our file system. No. And if I put another file with the same name, with the same information but bigger, if I append some information at the end of this file, you can see that the transfer is very fast because we check for every block the SHA, and only if this doesn't match, we retransmit this block. Okay.
Yeah, that's we are Python, and in many cases we can transmit for a single channel over 20 megabytes per second. Then I think this is a good speed for a Python application. Then in a different way, the perspection is much more, because if you have a 100 or better, where some megabytes of file, and you increase only a few kilobytes of file, the file of some kilobyte, that you transmit only kilobyte.
The real data instead are stored under TMP buckets, and here you can see all the buckets. And if I enter in the bucket of today, you can see the object. Inside the object, we have the single data. Each block is a file .dat, and each block is large 16 kilobytes, and every 512 blocks, we have one segment. So our data is stored by block and by segment.
Yeah, now it's possible to see on the disk because we use a driver on local disk, but all this information can use different type. For example, we have one storage based on directory. We have also duplication storage that can write on two separate directories the same content, and it's very simple, and probably we can show that it's very simple to extend the way that you want to store. No, everything is pluggable.
Now I'll show you how works our RPC. With this command, we can see the object which I stored in the bucket EuroPython. Which are stored under EuroPython.root. As you can see here, you see the free file which you can see on the S3 interface.
Yeah, if you want to build, that Restfs you can use as a storage, object storage, but if you want, you can use as a common file system. In case of common file system, we have some specific object. One is a file and one is directory, and you can identify with the type of the object, and we have a specific name. One name is the bucket.root, that is the root of the bucket and your file system that you start to create your tree. Then this is made automatically by the system, but yeah, if you want, you can create your file system without problem. You can see your file system as a normal file system. On the other hand, if you want, you can store the object like a database.
Now I can see some attributes of our object. You can see the object attribute here, and some information about the bucket, the block size, for example, the ID of the user, the segment counter, how many segments there are in this type of object, and so on, the segment size.
Yeah, the class of storage, because the type of the class of storage that you have in the bucket, we can decide to put your information in faster disk or in a safer disk, and so on. That's, you can understand immediately that this format is a JSON format. We use a JSON because we don't to close the client to use only Python. That the JSON, you can find the JSON library for all the language, and when you know the RPC format, that you can integrate in the language that you want.
Now I'm gonna show you how we think to spread the data on the network. So
yeah, now we start to work on a distributed hash table for make high availability and safer store the data.
This solution is based on Cadmelia. So, but we are again studying this solution to include this solution in our project. But I can show you how this protocol works. So I create a network of 8 nodes. Here you can spread the data on this 8 node. And if you see, when I retrieve this data, you can see that this data are stored in 3 nodes. The nearest, the previous one, and the next one. So if some node go down, this was automatically duplicated on the previous node, on the node. So we have always 3 replication of our data in 3 different nodes. So, okay.
Yeah, that's all.
Okay.
That's if you want to see something more, or you have some question on protocol or some specific implementation. Yes.
My question is more for end user. Are there any kind of easily available commercial people who provide this Restfs yet, or?
Well, first of all, it's more experimental today. It's an open source. We use internal to store the information, and we use the S3 interface because you can find the client on your Android or iPhone and many other computers. We don't have many data at the moment, but at the moment, we work more on development side than commercial side. That's commercial side is welcome, but that's for us is an open source project at the moment. Probably 1 year, no, or more. Any other questions? Any other question? Yeah. Whoa.
You noticed there that you're selecting which server to get the data from based on latency. If everyone is, say, in the US, isn't that going to cause a massive hotspot?
Well, Now I can't show you that. Everything is pluggable. Also, they decide how to the algorithm to decide which server. At the moment, we use 2 algorithms. One is a simple ping, HMP protocol to understand the RTT time. The second is to receive all the information of each server. That means number of connection, load of CPU, and how many resources is still available. Then you can decide. Then you can combine the 2 things. But it's very simple to extend if you want to create a new system. That's, for example, in the AFS, the decision in NFS in the past was based on the network. Today is more based on the time that you answer. That's happening in many other protocols because when not in the ECMP protocol, but application ping. That application ping, that means you have to calculate, make an elaboration, and to answer that the load of application is true, that more than ECMP protocol. But anyway, this is more simple. That's if you are at the moment in the United States, RTT probably is the winner, the time and the least. And when you stop to receive information from one, you go down. And also, we use a DNS algorithm that every amount of time increase the RTT. In this way, you have to recalculate the list because the network can change. One time you are connecting a wireless and you plug in a cable, and probably you use a different routing, and the RTT time could be changed. Then we calculate continuously, not continuously, but every amount of time, the lag. Today is very simple.
I saw you splitting the file into fixed size blocks and then calculating the checksum of each block. If you have, say, a sorted file or an index and you insert data in the middle that breaks down, is it possible to use something like the rsync protocol that handles changes that are not necessarily at the block boundaries?
We in most of time we try to do this control with the segment, because when the segment is a list with all the hash, then you can understand. At the moment, each single operation is atomic. Then, you can. We don't decide yet if you want the atomic commit all the information, or make incremental, keep corrupted the file. This is still open, this question at the moment. I don't know if I answer to your question. Yeah.
You say this is all experimental, so it's basically research work. So I'm just curious, what's your motivation, or to put it in a more pragmatic way, who's paying for this?
No, we have a slide for that donate page. No one, more or less. is our free time, and the motivation is quite simple. I come from a long experience on OpenFS and the research of perfect file system, and I didn't find. And I try to put together all the best of each file system, because we get the cache from OpenFS, we get in some ways something from Hadoop, we get something from Lustra, we get the idea of bricks of GlusterFS, we get RPC code from a long way, and rsync from difference, and so on. We try to put the best of many file systems in one place. Today, the problem is to distribute, and also, the logs. That's the logs is a big problem, because you can use an approach on like S3 that you don't care about that, or more on Lustra that you have to make a sophisticated locking system, because you can, or also Ceph know that you can increase the resource for handle the lock in a better way and distribute the lock in more small pieces than, at the moment we have a big lock. No, that is the same problem with the kernel. Other question? Yes?
If I understand correctly, it's also somewhat similar to Cassandra?
Yes. Yeah. We are, on the distribution of the blocks, more or less, because we use a circular distribution, the Camellia, that is more or less the same as Cassandra. Cassandra, yes, is good for Facebook, because the storage system, we are more agnostic. No, we are more object-oriented. No, we are an object with a lot of attributes, and no more. The Cassandra, now you can create a row with the similar things, and it's more specific for Facebook than, for in the backend we have some similarity. Any other question? Let me see. Yes, sorry?
I'm just wondering, how much data and how many files do you currently have and what you're currently testing?
This is we have we have a domain, we have a bucket, we have an object. That we have a test case with some million of objects and some thousand of bucket in a single domain, but for test purpose, no more. We don't care on dimension, because for me is a problem of the backend, and I don't write the backend because we decide to, with the driver, we decide to use, for example, today we use Redis because it's very fast, and we will see it. And probably when you reach the limitation, you can decide to increase the number of server, or increase or change bucket, or change your backends. Then I don't care about that.
So, but how much data do you have right now?
Real data that we use, I think probably 5 or 7 gigabytes. Real data, that not testing data.
So what is the largest system you have tested in terms of data size, just so I can understand how far you've scaled so far and how big the likely future challenges are?
Well, we do only one single domain with more or less 200 gigabytes at the moment. No, sorry, 200 terabytes. And we have in production 10 terabytes, more or less. That's the testing is around 200 terabytes, and the test environment, and and on a single domain, because for us is we can increase with more server. That is we never test the hand up, the top when everything is broken down. That's we have to test for the next time. Well, okay. Yes.
You mentioned that this is, I guess, an experiment. Does that mean that you wouldn't recommend using this in production?
It's not good for production until September. because no, we start to, rather, I think in September we have the S3 interface and system in the S3 on single server with storage on hard drive, stable today, that we expect in 3 or 4 months that we discover all the problem on the S3 interface. We don't recommend until next year probably the RPC interface. But I think you can receive a lot of advantage also on S3. The idea of S3 interface, because if you want to set up your storage, cloud storage, you can't. You can't find the software. You can't replace of S3. This is that's the basic idea of S3, that if you want to set up your small environment with S3 interface, you can't. Now you can. Yeah. Yes. Most of the part is based on dictionary. No other question? Sorry. Yeah.
Hi. Just a question for the file system. I saw that the segments and all the metadata, it's stored as an actual file in a normal file system. Will it scale, or for the future do you plan to implement your own file system for that?
Is already present, because you can read and write file from a Fuse interface. That is an experimental we didn't show, but we have a Fuser that you mount as a normal disk.
Sorry, my question was for the server part, so for storing the actual data on the server.
Yeah, now we can store in a partition. In the future,
NFS or
we don't have problem about that.
So normal file system.
Yeah. For example, the idea on the NFS is that you can mount 2 NFS from 2 different servers, and we write in 2 directory. Then if you lose one NFS server, you have a mirror system, for example, for free, without problem. Yeah, the work is more on distributed hash table. That is a big leap for Restfs. Yeah. Yes.
So if I want to try this out, is it pure Python? Can I just run it on any system? How do I install it? Is it just, can I easy install it, or is what's the procedure?
Yes, today is Python. We have we use, but yeah, we use where it's possible C library, for example, in Pickle, and for serialize, and some encryption. If you have the library, the C library is much better, but we are pure Python 2.7 at the moment. And the Fuse you can use only in the Linux and BSD, FreeBSD, and the Mac OS. We don't have at the moment solution for Windows. We use S3 interface. Yeah, most of the part inside is based on diction. Any other question? Yeah, okay. We use key everywhere as much as possible. We have 2 separate lists on the segment. One list is based on the ID of the block, and one is based on the hash of the block. That with the first one you can retrieve the object from the server. With the second one you can understand if something's changed on your data. And I already mentioned that the property, we have an extended property. We have an MD5 that you can control that something's corrupted between in the transmission, and max read and some other information. Serial and property we already said. That's the importance of subscribe and publish. You can understand immediately that if you have a large number of clients, you have a lot of bandwidth waste for pooling. Then if you send a message only when something is changed, you have a big saving of bandwidth and also in performance. This pattern matching, we can subscribe a set of information that is not only a single object. Distributed cache, because on the domain we try to reduce the number of calls to the backends. And the client cache, we have a circular cache at the moment with write through, because we reuse the block. We allocate all the block in the cache, and we reuse the block. Yeah, we use on the protocol, on the RPC, we use a WebSocket. That means we have an open connection, permanent connection to the server. We use a JSON RPC because it's very simple. No, it's very simple to implement. This is an example. It's not our RPC, but now you have a method that you need and parameters. That everything based on dictionary. And yeah, at the moment we use a BSON encryption, encoding type. Yes.
Just one thing I thought of there. You, in the background beneath all of this, you're storing things in pickles. Does that mean then that I have to use Python 2.7 everywhere, and if I suddenly use 3 or 2.2, I'm sort of a little screwed? Why do you use pickles?
We use this. Yeah, this is a problem. It depends on which level serialization we use. No, that there are compatibility levels. We use pickle to serialize the object and store in the backend, because we want to. The backend is agnostic on the information that is stored, and it's very simple to write the code for new driver. If you want to use Oracle, for example, we don't use Oracle. You have simple to save and retrieve the information based on the key, and the information is serialized. No, we lose the advantage of database in some case, because you can create index on the element that you have in the object that you save in the database. But on the other hand, it's very simple to write a new backend or a new driver for the new backend. That's the store. No, that we start to use. On the other hand, on the pickle, we use a most common compatibility serialized object. No, because if you make an upgrade, you don't have to reconvert all your database. But I don't know in the future.
Couldn't you just use JSON to store?
Yeah, this is a big discussion about that. I know that, for example, MongoDB use BSON. For this reason, we start to use BSON for transmission and for store some information in the backend. I'm not sure is that the perfect solution for that. I'm not sure. That's we can change. We are experimental. I can change my idea tomorrow. And I don't have a large customer base. We have more time to consolidate some decision. At the moment, I prefer pickles. Yeah. Well, on the security channel, we use S3 HTTPS and WSS for WebSocket. We have internal or identity provider like Google, that in Facebook, that you can retrieve and you check the password with the external system. We have a token. We have authorization system based on ACL, we already mentioned, and we have encryption. And this is still in development. We want to use GPG. That's because you can encrypt client side in this way that the people that handle the backend, the server can decrypt your information. But you have also I want to give you the possibility to share this information with others, and we want to use the GPG system to exchange the key and so on. But this is still in design. Yes. Yeah, we already mentioned about Camellia. The Camellia is very simple for store. It's decentralized. You don't have a central point, and more or less a good distributed system. On the back end, we use today Redis. Why we use Redis? Because Redis can handle more or less 60,000 users for 60,000 operations per second. That means this operation is equivalent of I/O operation for a normal storage system. And if you buy a MC square, probably you have 20,000 operations per second. That means we are 2 or 3 times over. Well, today the big problem is when you split the file and distribute all the blocks, it's difficult to maintain how many space you use, or you are still using, or when you remove, that everything works in a metadata, in a database, but you don't. It's difficult to reconstruct how many space you have and how many space is still free. Well, is a Python. We already said we use file system. We use today for SQL in special way SQL Alchemy. for the interface with SQL. WebSocket, JSON, RPC, encoding plain, JSON, callback. You use the subscribe and publish from Redis. And the hash, you can decide the hash that you want. And that's more or less, you already discovered these things. But what is good for, you can use for home directory, that you can retrieve your information everywhere. We want to introduce a disconnected operation. At the moment we don't have disconnected operation, but it's simple because it's simple to maintain all the distant information in local site because we have a cache and we have all the information. That's probably one of the next steps will be in a disconnected. You can use on the application layer directly as an object storage or a shared space between different systems or a virtual machine. Another one thing that we have in development is to clone an image of machine, and in this case you can clone one image in 0 time and start to write only the difference, that you have a master gold image that you can replicate on all the time that you want, and you save space and saves time, and increase the performance of a virtual machine or better virtual environment. You can use also with a content delivery network or data replication or disaster recovery because we don't have a single point of failure. Well, this is a sub-project. We start to write a disaster recovery through Samba. We intercept all the traffic from Samba and send to another site. We have probably most advantage compared to more important storage like S3 or Dropbox or SpiderOak or Sugar Sync because, we have a higher reliability, unlimited scalability, and so on. Well, the point, we release 0.1 today to public, more or less. Probably in September we have the DHT and the storage encryption and compression for everyone. And we release also the Fuse because it's very unstable at the moment, the Fuse. 0.3, the duplication we already mentioned, and we have many things, locks versioning. That's because with our structure it's quite simple to create a versioning system or more async operation or more replication or distribution algorithm. That's we have to, thanks to ZeroPu, that support for hardware and give us the 200 terabytes for our test. Donate if you have time, because we are basically free for everywhere and everything. That's if you have time for code, also ideas. Testing could be said. If you want to insult, so that you can. That is important. Also, sometimes receive some insults. But anyway, that's a small advertising. That's 25 and 26 of August, St. Augustine, a nice conference that is very important point today in Europe. Any other question? Yes.
So 2 slides ago I saw you had negative caching as something you were going to feature, and you're also using persistent caches and so on your clients. Do you actually promise consistency? Your system, are you going just for availability and partition, or can different clients see different things at different times depending on how the network's acting?
Not at the moment, because we don't have a we have many branch and many experiment with all single component. At the moment on the Fuse that is not stable, we check the serial number of each object before to return to the system. That is quite impossible to see different things. This is one of the differences that we have with S3, for example.
Okay, so there's time for one last question. If someone has one.
No more questions. No more.
Okay, so the next talk will be from Nicola Rosa about Alpha for Jigs, and see you in 5 minutes.
Tieni l'acceso. Okay.
Regia, con ravioli abbiamo finito.
Con i ravioli passiamo agli spaghetti.